In this video, I'm going to look at problems 1 through 8 on the Chapter 3 exam review. Now this section says to solve each system of equations by graphing. So in number 1, we see that we have two equations, y equals x minus 1 and y equals negative 1/2 x minus 4. So I'm going to graph each one of those lines independently, and I'm going to see what kind of relationship they have. So here we go. Here's the first one, y equals x minus 1. I know the y-intercept is negative 1, so I'm going to put a negative 1 right there, put a little dot. And then my slope is a 1, it looks like, so I'm going to go up 1 over 1, up 1 over 1, up 1 over 1. Or likewise, I can go down and back 1, down and back 1, down and back 1. Okay, so I'm going to get my handy-dandy straight edge here. And I'm going to go ahead and draw this first line. Okay, and the second line is negative 1/2 x minus 4. So I know it's going to cross at negative 4. And it's a negative 1/2 slope, so down 1 over 2. I can't go any further, so how about up 1 and back 2, and then up 1 and back 2. So when I go ahead and draw this line, it's going to look something like this. So I can see that I have a point of intersection right here at negative 2, negative 3. So that's going to be my answer, my solution. So I'm going to put negative 2, negative 3, and that's my answer. And if I were to classify this system, I would classify it as consistent and independent, since it has exactly one solution. In problem number 2, I have two more equations, and we're going to graph them both on the same Cartesian coordinate system, and we're going to see what kind of relationship they have. So the first one is y equals 2x minus 3. So I'm going to start down here at negative 3, and my slope is 2, so really it's 2 over 1. So up 2 over 1, up 2 over 1, up 2 over 1, or I can go down 2 and back 1. So that'll be the first line. So let's go ahead and draw him in. Okay, the second one is y equals negative 3/2 x plus 4. So I'm going to come up here to 4, and I'm going to use my slope of negative 3/2. So down 3 over 2, down 3 over 2, and it looks like that's all that I can go on that one. So whenever I bring him up, this is what, let's line those guys up, draw my line. So that's what those two equations look like when I graph them. And it looks like, again, I have a point of intersection. Looks like it's going to be 2, 1. So that's my answer. So I'm going to put 2, 1 as an ordered pair, because that's the point of intersection. So if I was to classify this, I would classify it as consistent and independent because it has one solution. In number 3, I have two more lines. I have x equals 1, which is going to end up being a vertical line, and then y equals negative x minus 3. So let's go ahead and put my vertical line in first. I know it's going to cross at 1, and it's going to be vertical, so it'll go through all those points right there. So I'll bring my straight edge over. My little index card here is what I'm using. And there's my vertical line right there. Okay, so my other line is going to be negative x minus 3, so it's going to cross at negative 3 on the y-axis there, and it's going to be a negative slope, so down 1 over 1, down 1 over 1, or I can go up 1 and back 1 to get my negative slope. Anyway, so those are some points that I can use. And now let's go ahead and draw this rascal. Okay, so there's that line. And it looks like we have an intersection right here. It's going to be at 1, negative 4. So I'm going to put my answer 1, negative 4. And this is going to be a consistent and independent system because it has exactly one solution. In problem number 4, I have two more equations, y equals negative x plus 2 and y equals negative x minus 4. So I'm going to go ahead and graph them each. Let's do negative x plus 2, so I know it crosses the y-axis at 2. And with my negative 1 slope, I know it'll be down 1 over 1, down 1 over 1, down 1 over 1, or it's going to be up 1, back 1, up 1, back 1. So I have a line that's going to look a little bit like that. Take my straight edge and draw my line. And again, when I draw my lines, I'm going past the edges of the graph and I'm putting arrows on the ends, indicating that it goes forever in that direction. So my other one is negative x minus 4, so I know that I'll be down here at negative 4. Same slope, so down 1 over 1, or up 1, back 1. So when I draw this line, I'm going to notice something. I notice that, hey, these lines don't intersect anywhere. In fact, they're parallel. We knew they're parallel because they have the same slopes. So parallel lines, and when we classify that, it's going to be inconsistent because it has no solution. And I'm going to go ahead and write no solution right down here for the answer. In number 5, I have a couple of equations here. X plus 2 equals negative 2y, and then negative 8 equals negative 2y minus x. Notice neither of these equations is in y equals mx plus b form, so I'll need to do that so I can graph them. Okay, so it looks like this one's almost there. We have the y almost by itself with the other stuff here. So if I divide everything by negative 2, I'll have x over negative 2 plus 2 over negative 2 equals negative 2 over 2y. What that does for me is those cancel out, so I just have y all by itself now, and then I'll have negative 1/2 x minus 1 on that thing right there. So my slope then will be negative 1/2, and my y-intercept is going to be negative 1. So I'll go ahead and graph that first one, and then negative 1 over 2, or up 1, back 2, up 1, back 2. So that'll be my first line, and I'll go ahead and get my note card straight edge here. So I'll draw him in. Okay, and the other one is going to be negative 8 equals negative 2y minus x. So I'm actually going to switch the y, put him over there, and the 8, put him over here. When I do that, I'll slide it over here, I'm going to have 2y equals negative x plus 8, and then I can divide everything by 2. So really I'm going to have y equals negative 1/2 x plus 4. Okay, so I'll start up here at 4, and then I'll have negative 1 over 2, so down 1 over 2, or up 1, back 2. And so when I graph this guy, let's get him in there, there we go. It looks like, again, we have some parallel lines here. So our slopes were the same, both of them were negative 1/2. So they're never going to cross, so that means there's no solution. So I'm going to write it, no solution down here. And that means if I were to classify this, it would be inconsistent because there's no solution. In number 6, I have a couple more equations. I have this 3y equals negative x plus 6, and then 0 equals 6 minus x minus 3y. Well, on this top one, he's almost where he needs to be. There's 3y, so let's just divide everything by 3. So 3y equals negative x plus 6, and I'm going to put it, divide everything by 3, over 3, over 3, over 3. So this guy ends up being y equals negative 1/3 x plus 2. Let's go ahead and graph him. So the plus 2 means we're going to start up here at 2 on the y-axis. The negative 1/3 slope means down 1 over 3, down 1, oh, I can't go off there, so up 1, back 3. And then I can't do any more points that way either. So let's go ahead and use my little straight edge. Okay. So there's that line. And the other one, let's just put this negative 3y on the other side to make him positive 3y. And then I'm going to switch those around so I have negative x plus 6. And it looks to me like when those cancel out, I'm going to have y equals negative 1/3 x plus 2. 2 at the y-axis right there, and the negative 1/3 slope. Actually, they're the same lines, aren't they? Same equations. So if I were to draw the second line, he would just be right on top of the first line. So the answer to this is infinite solutions. Infinite solutions is what I'll write. And these lines are what we call coincident because they lie on top of each other. They are the same line. And if I was to classify this, it would be consistent and dependent. So on number 7, I have two more equations. This 2x minus y equals 3. Let's look at him first. So if I bring this 2x on the other side, it'll end up being negative y equals negative 2x plus 3. And then I can divide everything by negative 1 to get rid of the negative. So it'll be y equals positive 2x minus 3. Okay, let's go ahead and graph him. So I go down here at negative 3, and my 2 over 1 slope will be up 2 over 1, up 2 over 1, so forth, or down 2 and back 1. So let's go ahead and see about graphing him. There we go. And the other one is going to be this 0 equals negative 12 plus x plus 3y. So I'll just bring this 3y on the other side, make him negative 3y equals, and I'm going to switch the order there so it's x minus 12. And then everything gets divided by negative 3. So y equals negative 1/3 x plus 4. So I start up here at 4, and the slope is negative 1/3, so down 1 over 3. Or I can go up 1 and back 3. So grab my note card straight edge here and draw this line as well. Looks like I have a single point of intersection again, and it's going to be over here at 3, 3. So my answer for this problem is 3, 3, that point of intersection. And if I was to classify this, it would be consistent and independent because it has exactly one solution, the place or the point there of intersection. And the final problem, number 8, in this section, is going to be 2x plus y minus 1 equals 0, and also have 0 equals 3y minus 6x plus 9. So we'll tackle the first problem first. So the y is almost by itself here. We need to get this 2x over there and then the negative 1 over there. So when we do that, it'll be y equals negative 2x plus 1. So my y-intercept is 1, and my slope is negative 2 over 1, negative 2 over 1, negative 2 over 1, or I can go up 2, back 1, up 2, back 1. And I'll bring my straight edge over. I'll draw that line just like that. Okay, arrows on each end. And then how about let's do this last one. So we have 3y minus 6x plus 9. Let's get that 3y on the other side. So it'll be negative 3y equals negative 6x plus 9. And then when we divide everything by negative 3, it'll be y equals 2x minus 3. So minus 3 is the y-intercept, and up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, or we can go down 2 and back 1. So we have our slope there as well. And it looks like we're going to have a single point of intersection, and it's going to be here at 1, negative 1. So my answer is 1, negative 1. And if I was to classify this system, it would be consistent and independent.